From the surface of the ocean, it's easy to believe that Earth is a known world, mapped and measured, familiar and safe. But the moment we begin to descend, that illusion starts to fracture. Because within minutes, the sunlight weakens, colors begin to drain away, and a deep, unsettling silence replaces the noise of the surface. And as we sink farther, the ocean stops feeling like a place and starts feeling like an absence. A vast vertical void where direction loses meaning and time feels suspended. And somewhere around 200 meters down, the last fragile threads of sunlight finally disappear, leaving behind a world that has never known day, never known warmth, never known the reassuring presence of the sun. A world ruled entirely by pressure, cold, and darkness. And it is here, in this permanent night, that something impossible begins to happen. Because in the middle of absolute blackness, a faint glow suddenly appears. Not a reflection, not a trick of the eye, but a living light, drifting slowly through the void like a star that has lost its sky. And then another appears, and another, until the darkness itself seems to pulse with quiet sparks of blue and green, as if the ocean were revealing a secret language written in light. And this is the moment where a simple question begins to feel disturbingly inadequate. Because it is no longer just why do deep-sea fish glow, but how does life decide to create light in a place where light should not exist at all? Because here, everything about survival works against the idea of brightness. Energy is scarce. Food arrives unpredictably, sometimes weeks apart, and every movement risks attracting something hungry. Yet instead of hiding completely, life here has evolved to shine, to glow, to advertise its presence in the most hostile environment on Earth. And scientists call this phenomenon bioluminescence, a word that sounds clinical and neat, but fails to capture what it truly represents. Because down here, light is not decoration. It is not beauty for beauty's sake. It is a tool, a weapon, a disguise, a warning, and sometimes a lie. And as we descend deeper into the twilight and then into the midnight zone, past 1,000 meters where no sunlight has ever reached in human history, we begin to realize that glowing is not rare here. It is the default state of life, with tiny fish carrying rows of lights along their bodies like runways suspended in the void, jelly-like creatures pulsing softly as if breathing illumination itself, and shadowy forms flashing suddenly and vanishing just as quickly. And each glow tells a story, though not one we fully understand, because in a world without vision, light becomes communication. A flash might say, "Stay away." A steady glow might whisper, "Follow me," and a sudden burst could mean panic, danger, or death. Yet this raises an unsettling question that scientists still struggle with. Because if light is a language, then who exactly is it meant for? Especially when predators are watching too. And nowhere is this contradiction more visible than in one of the deep sea's most infamous hunters, the anglerfish, a creature that appears almost unreal, drifting motionless in the dark with a grotesque calm, its body barely moving, conserving every bit of energy, while from its head dangles a small glowing lure, swaying gently like a promise. And this light is not random, not accidental, but precisely designed to exploit hunger in a place where hunger is constant, drawing smaller fish closer and closer until the darkness suddenly collapses into teeth. And what makes this even stranger is that in many species, the anglerfish doesn't even produce this light itself, instead relying on glowing bacteria housed inside a special chamber, a silent partnership forged by evolution, where the fish provides shelter and nutrients and the bacteria provide light, turning the animal into a living lantern powered by microscopic life. Yet despite decades of study, scientists still do not fully understand how the anglerfish controls this glow, how it dims it, brightens it, or turns it off entirely, or how it prevents predators from using that same light against it. And as we continue descending past 2,000 and then 3,000 meters, the pressure becomes unimaginable. Enough to crush steel, enough to erase air pockets, enough to turn rigid structures into weaknesses, and the creatures here do not resist it. They surrender to it, their bodies becoming softer, more fluid, their movements slower and more deliberate. and their use of light more refined. Because here we encounter fish that glow not to be seen but to disappear, emitting a faint light from their undersides that perfectly matches the dim glow filtering down from above, erasing their silhouettes so completely that predators below see nothing at all, a phenomenon known as counter-illumination, which requires an almost impossible level of precision, because glowing too brightly would expose. As we continue descending beyond the reach of even the deepest research submarines, the ocean begins to feel less like an ecosystem and more like an alien universe layered beneath our own. Because down here, depth is not just distance, it is a transformation. And at around 4,000 meters, the pressure becomes so immense that the idea of solidity loses meaning entirely. Metal creaks, glass thickens, and even light itself seems hesitant to travel. Yet life persists, not aggressively, not loudly, but with a quiet patience that feels ancient. And here the glow changes again, becoming rarer but more deliberate, more controlled, as if every photon released must justify its cost. And this is where scientists begin to notice something deeply unsettling. Because the patterns of light no longer seem random or purely reactive, instead appearing rhythmic, intentional, almost strategic, with slow pulses that repeat over minutes rather than seconds, lights that brighten only when another glow appears nearby, and then fade again, suggesting not just communication, but awareness, a possibility that makes researchers uncomfortable. Because awareness implies choice, and choice implies a level of complexity we are not prepared to confront. And in this crushing darkness, we encounter creatures whose entire bodies are transparent, barely more than drifting outlines. Yet embedded within them are pinpoint lights arranged with geometric precision, spirals, lines, clusters that resemble circuitry more than biology. And no one knows exactly why these patterns exist, because they don't clearly attract prey, they don't clearly repel predators, and they don't seem optimized for camouflage, which raises a troubling question. Scientists still cannot answer whether some deep-sea light exists for reasons beyond immediate survival, perhaps linked to development, navigation, or even social interaction in ways we have not yet learned to observe. And as we descend further, into depths exceeding 5,000 meters, the environment becomes almost entirely static, currents slow, movement becomes rare, and encounters between organisms may occur only a few times in a lifetime. And yet even here, faint glows appear, sometimes hovering motionless for hours, like sentinels guarding nothing, and at other times drifting slowly upward, then stopping, then descending again, movements so subtle they defy explanation. And when researchers attempt to follow these lights with cameras, they often vanish abruptly, not fading naturally, but cutting out as if switched off. A behavior that suggests control mechanisms far more sophisticated than we once believed possible in such simple-looking life forms. And this is where the story of deep-sea bioluminescence begins to blur into something more unsettling. Because when scientists analyze footage frame by frame, they discover instances where light appears to respond to observation itself, brightening when illuminated by submersible lights, dimming when approached, changing frequency when sonar pulses pass nearby, raising a deeply uncomfortable possibility that some deep-sea organisms can detect not just light, but intrusion, sensing disturbances in their environment that we barely understand, and reacting accordingly. And this brings us to one of the most disturbing discoveries of all, because not all deep-sea light is visible to the human eye, and not all glowing is meant to be seen by us at all. As recent instruments have detected flashes in wavelengths outside our natural perception, ultraviolet patterns, near-infrared pulses, signals that suggest an entire layer of communication occurring in complete secrecy. And this raises a larger, more unsettling question. Because if life down here is exchanging information using signals we cannot naturally detect, then how much of the deep ocean's activity has been happening around us unnoticed? Not hidden intentionally, but simply invisible to our senses. And as exploration pushes closer to the ocean's deepest trenches, places like the Mariana Trench where pressure exceeds 1,000 times that at the surface, the few robotic explorers that reach these depths report something unexpected. Because instead of complete emptiness, cameras capture brief moments of light emerging directly from the seafloor itself, not attached to visible creatures but rising slowly from cracks and sediment like ghostly embers. And scientists are still debating what these lights represent, whether they are organisms adapted to live within the seabed, chemical reactions triggered by geological activity, or something else entirely, something alive but unfamiliar. Because samples brought back from these regions often fail to survive decompression, leaving behind more questions than answers. And what makes this even more disturbing is that in some recordings, these lights appear to respond to each other across distance, brightening in sequence, fading in patterns that resemble coordination.